All right, we're here. So I think I'm set to get going. Technology. Anyway, so we're alive and kicking. See if my slides work. So I always start out with pictures while we wait for people to show up. Isn't quite 10 o'clock yet. Um, this is one from the day 2 class in the fall. That back then I was at our cottage, and this was looking out at just before 7 o'clock in the morning, and uh, beautiful sunrise. It was very peaceful, and the I must say this place does help me in that regard. Even during a hurricane, it's can actually be a comfortable place. In the city, I've got huge trees hanging over my house, and so if we're in a hurricane, worried about are they going to all crash on me? Those sorts of things. Anyway, um, little different because a different time of year. This was this morning. It's a very poor quality image. Again, I'm using a very old smartphone that has a very poor camera in it, and there was very little light to work with. So this was at 7 o'clock. At 6:52, it was still too black. So looking out, similar direction, out over Kingsburg Bay, and I don't know if you can see it right in the middle, but there was just a little tiny piece of a moon that was sitting out there. And you might see some little white dots. These aren't defects because of the poor quality camera I'm using. Those are 2 fishing boats that were out there. And in total, there were probably about 12 out just before sunrise. And they were 2 groups. There were ones that had little lights, like those ones. Those were likely lobster boats. Lobster season started at what around Christmas time, and it continues till May. And so, most days when the weather is not stormy, we'll see lobster boats out checking their traps and resetting traps and that sort of thing out in the bay. But there are other boats we'll see out there, and the lobster boats tend to come out just before sunrise, and often the water is calmer at very, very early in the morning, and so it's easier for them to do their work. Uh, but there is another group of boats that are out at night. Uh, we thought they um, initially are they people dropping off drugs and smugglers and that type of thing? Because they would be bad smugglers if they're using the bright lights that they do. Stupid me. Didn't think that they're tuna fishermen, or they're fishing for big fish, tuna or shark, and they do that by using very, very bright lights that they shine at the water, shine out around, and they are super bright. You see them from miles and miles away. Um, but they attract all the little tiny fish, herring and other sorts of things like that. And as they swirl around the boat, the big fish come chasing after them. So to attract the tuna to where the fishing boat is, they attract the bait, the fish that the tuna will chase after, and fish for those sorts of things. Interesting. So this morning was an unusual day in that we saw both sets of boats out there just before sunrise. So it was a interesting morning. Now, I've asked you to submit pictures to me, and I've gotten a few of different sorts of things, of different images where different people are. In the 8:30 class, I know I've got one student that's in Mauritius. I hope he or she sends me some photos. When I start up my computer each morning, I presume it's Microsoft, goes and puts an image on my login screen, and it varies from day to day. The last few days have all been images from Mauritius, and interesting country that one is. But anyway, this Osama sent me. He is in an apartment in the Clayton Park, Fairview area. So that's a fairly high hillside that overlooks the Bedford Basin side um, of Halifax. And in the middle there is the container pier. So I guess he watches, like I watch the fishing boats, he watches the container uh, boats come in and out of our harbor. But uh, it's um, some things that reflect where you are. And as I said, the 8:30 class, I've got a variety of people in different locations in Ontario and New Brunswick, some of them. They said it was super cold this morning, like it is here, but probably colder, at least in New Brunswick. Um, at Mauritius, they said it's a little bit cool because a cyclone is passing through. I still can't imagine it being like here. Um, uh, as of last night, I was going through checking to see who has registered with Top Hat and who hasn't. And there were still had about a dozen students. Um, so they're no doubt not on this class this morning because they're not in Top Hat. Uh, and That's the only way they can participate in the course. But with some of them, I suspect the problem is their email, and this may apply to some of you as well, that it's a problem I see more often with first year students than returning students, that I've been communicating and putting announcements out to you by email, and I use the email that I pull from Banner, and the default one I pull from Banner is your what you call we call preferred email. And so you can have multiple email addresses in Banner, but one of them is your preferred one, and that's what we communicate with. And some students, to access Office 365, set up a St. Mary's email account, and some inadvertently set it as preferred, even though they generally use their Gmail account or Hotmail account or Yahoo, what have you. If you don't use your St. Mary's one, please go into Banner and change it so that your preferred email is the one you use the most often, and then you won't miss communications from us. Unless, of course, you want to miss communications with us. And please, I'd encourage you to participate in the survey that we've got out, and I'll talk about it in a minute. Next slide. There we go. With quiz one, only one person didn't participate. Good. And I've tried reaching out to that one student to get them into the quiz. I don't think there were any quiz scores below 9. There might have been a couple. But the average, it was 9.7 in one class and 9.8 in the other. So great. That's where I want to see them. And if the class average is below 9 on any quiz, then I'm going to be worried something's wrong. Probably I made an error in the solutions or in the answers. That I'm with the quizzes, it's to an incentive for you to review the course material, and that so I'm trying to reward you as much as possible for doing that. That for those students, if you got a 9.5, how'd you get it? Well, you got the wrong answer to a question, but we gave you half a point for participation. And so just for trying a question, you get half a point. I might reduce that later in the term once I've got you all participating a lot. But still, the grade should be high. We've also posted a discussion question. You get 1 point towards your discussion score each time you participate. I do go through and read those. So I'm looking, I'll probably take away the point if you're just putting in garbage in there. But I read through a large number of them last week, and uh, very good comments they're putting in them, that they're not unexpected. I'm not saying any of them are right or wrong. Out of my students, I've got 99 that participated, so almost everybody did, which is great. It's really good. Remember that, and it's still open, so if you haven't participated in the discussion, you can still join in. And that in the course that I'll be posting these most weeks, but no guarantee for every week. But if you participate in 8 discussions, you get 8 points. So that would be like replacing your worst test score with an 8 out of 8 test score, 100%. Big incentive there. But please be thoughtful and think about the questions and giving me input on it. Most of the comments have to do with how you've been affected by online ads, but there's an awful lot of things that have been companies have done to you don't know about because they're keeping that knowledge they've got hidden. Some have talked about how stupid some of the ads are. They sent me an ad for a product I just bought. They're too late. I just bought the product. Those might be viewed as stupid ads. They haven't used that data in a thoughtful fashion. But others can be very devious and creative in how they're using it. And those ones, the better they are at doing it, the less you're detecting it. They don't want to scare you away. With respect to the survey, last night when I was editing these slides, I had 103 responses out of 340, 340 or 350 students are registered this term. We're down about 100 students from last year. Last year we had 344 in the end that participated. So this term, I'm looking for at least 250. I want a good size sample, and we'll be talking sort of about that next class on Wednesday when we're into talking about data, but large samples are generally better than small ones, not always. But I'd like as diverse a group of responses as possible, and we'll be using this for analysis. So I sent out a reminder last night, and overnight we had another 30 or so students join in, and I'm going to keep annoying the people that haven't participated until you do, or probably sometime next week I'll turn the survey off. In the survey questions, a lot of them, if you haven't participated, are fairly traditional sorts of things. That when did you start at St. Mary's? What's your gender? That simple categorical or numerical types of information I'm collecting on you. But the ones that are interesting for me are the qualitative responses where I ask you to just write something like you get in the discussion questions. And that among those that there's what's your biggest fear? What are you most afraid of this term? And this in the fall was a very interesting one because so many students were really afraid of doing online courses. This was the first time they'd ever done it. And for instructors like myself, it was the first time we had done it. And it was so much unknown. And that caused a massive amount of stress. And so many students said that. And the other thing that they were afraid of this term or that term was their grades. And a lot had to do with how online was going to affect their grades. There was one group that was afraid of failing, and there was another group that was afraid that they had a scholarship and they'd lose their scholarship because their grades would go down. That scanning through the feedback I saw last night, the most common response by far was failing over and over again. The other things were spread around different stuff, but it was not the same as what I saw in the fall. You've had experience. Most of you were in classes in the fall, and so you've lived through some of this online stuff, and you have a bit. It's less unknown. You may not like it, but it's less unknown. But there's a huge fear about failing. So please put faith in yourself. If you do all the quizzes, if you do the tests, if you do the assignments, I'm not saying get them all right, but if you do them in and of itself, you're going to likely pass. That if you do it in a thoughtful fashion, you should be able to not only pass, but you shouldn't get less than a B. There's high chance you're going to get an A. That it's broken down into little tasks, and it's not that you might think the quiz grades I'm giving them away, but you're actually having to work to get them. You're earning those grades. And last term, generally the grades were very good, except for the students that didn't bother to do things. They skip tons of things. Those are the ones that failed. Those that did the work, they all did well. Um, they oh, I didn't have it. It was interesting though. The comment. The other big open-ended questions are, what did you like most about last term? What was the best thing about last term? And what was the worst thing about last term? And for both questions, the most common answer was online courses. That I wasn't surprised with those that didn't like online classes, and a large number for a variety of different reasons they didn't like online classes. But I was quite surprised by the huge number that really did like online classes. There was certain aspects of flexibility that allowed them to do other things. So that um, they seemed to be satisfied with the learning, but they were able to adapt to that environment well. That doesn't apply to everyone, but for one community of students, they found it very beneficial. If you haven't answered the survey, and especially if you like online classes, I encourage you to respond, because there's a widely held belief among faculty that students don't like online classes. And so when we're over COVID, we're going to go back to the way we used to teach before. And we're not necessarily going to, before we didn't offer many online classes. And what we did, we're not very good. Um, that your input will probably encourage the university overall to develop a better online presence. So for those students that like it, that option is going to be there. For those students that want the face-to-face, we've still got to have that. It's not one or the other. But uh, I've heard a number of comments lately that there was a feeling then, and once this is over, that online stuff is not important. And for one group of students, they've said very, very loudly, it's very important to them. Anyway, on with today. I We've said what data mining is in the last class, and today I've got two things. One is to try to describe some of the most common applications. We will visit them in more detail as we go through the course, but to give you a quick introduction to main categories of different types of problems. And the other is to start describing a process that we will work through, and all the lectures are organized around, from how do we get started on a problem to how do we wrap it up and finish that problem. And the process for me is the most important part of the course. That processes are and frameworks are very, very valuable in solving problems. Tools are less important because I can always look it up again if I've forgotten how to use the tool. But um, changing the way we think in processes is really, really important. So why study these applications, even if we don't get into them? It may have to do with the role you have, and I don't necessarily see you having, all of you, as a future as data analysts. Just like when you take accounting, you aren't necessarily going to become an accountant, but it may be helpful to be familiar with accounting and those things. That the If you're not a data analyst, you need to know what can they do for you. They're playing a support role in many instances, and how can they help you do your job more effectively? And what should you be able to ask them to do for you? How do you talk to them? What's their language that they use? So that's one thing. And understanding applications gives you an idea of what could you ask them to do for you. From the data analyst perspective, it's uh, very helpful, especially when starting a problem. When someone's posed a question to you and you're saying, yeah, that sounds like a classification problem, or that sounds like a profiling problem, or that sounds like whatever problem. And then I'd think, well, what's what's best industry practice for doing a classification problem? Turns out there are lots of ways of doing it, but being familiar with different approaches then for those different types of applications. And regardless of the tool you use, it may be some of the issues and the challenges that arise with a classification problem. We'll sort of talk about that today in one context. Uh, but being aware of where the pitfalls are in advance is very, very important. So next slide. So the types of questions we're talking about is um, some questions that involve predictions, like here's a customer wants to sign up for a smartphone plan, and I'm trying to guess how many gigabytes of data are they likely to use? What type of plan should I be pushing them to do? Um, Maybe I'll probably push them to buy a plan that's more than they need, so encourage them to use more data. But I don't want to push them for a plan that's too small because they'll get frustrated with it. So having an idea, how many gigabytes of data do I think they're going to likely use? Or I've got a customer with their smartphone and, oh, their plan comes up for renewal on February the 7th. Do I think they're going to switch? Or do I think they're going to change to Rogers? If they're going to change, is there anything I could do to get them to renew their plan with us? Because they still haven't done it yet. They haven't told me. Maybe they've already made the decision to switch. Um, can I identify those customers before they tell me? Because when I find out, no, they've already switched, I've got a big job ahead of me to try to bring them back again. So I'd like to predict who is going to switch and who isn't. There are other applications which are just more descriptive. What's the typical behavior of this credit card customer? And maybe knowing that behavior, I can make predictions. But knowing the behavior first, that's my starting point. And I use that information for other possible things, is to um, try to get them to change their credit limit, to get them to take life insurance with us, to buy other types of services from us. And but as I said, there one might be sort of turning what we'd call a classification problem. Is this fraud or not fraud? By how does it fit the profile? And I took out a uh, TD Bank Visa card a number of years back, and that then encountered two instances where they used profiling on me. Once, both times incorrectly. Um, that I'd never been out of the country with my card before. When I traveled to Bermuda to recruit students, and at the end of my several days of recruiting students, I went to pay my hotel bill, and TD rejected my credit card. They rejected it not because I was exceeding any credit limit, but because they thought it unusual that I had been using it outside of Canada, and they thought my credit card had been stolen. It caused me some problems with the hotel, but we sorted those. 2 years later, I was in Jamaica. My daughter was getting married, and I used it down there. No problems. TD accepted every transaction, including a few after I'd returned to Halifax that were being used by someone that had stolen the number when I'd made a purchase in a store. And so there were several fraudulent purchases. In each instance, they were trying to compare the transaction. Did that transaction fit my profile? And it made mistakes both times on those ones. It was right on lots of other transactions I'd done. But those are how it used profiling to go and for fraud detection. That other ones, they're looking for patterns. That if you're shopping online, you might, after you've put something in your cart, they'll say, oh, people that bought X also bought Y. Are you interested in buying Y? They're trying to do some cross selling and get you to buy additional things. So they're looking for patterns in people's shopping. That uh, they're looking with some social networking stuff like LinkedIn, trying to encourage you to broaden your network. That way you'll use your network more. And they're trying to encourage more activity. And so they're looking at connections. They're predicting connections between them. Some are trying to simplify things. You've got millions of different customers. I can't have millions of different recruitment or marketing strategies. Can I cluster them into market segments where each segment is very similar? That they have the same shopping behavior, they have the same interests, the whatever. And so I'll let the data help form clusters for me of different things. That sometimes I've got too much data. That's often a problem. I know too many different things. And I can't look at all of those characteristics. It's overwhelming. So can I identify a small number that tell me the most important pieces of information? And or I've got too much data altogether. Can I use a smaller subset that uh, will still give me a good picture? So it's less resolution in it, but it's easier. It's like a smaller file to work with. If you're looking at taking pictures with your phone, some of them end up being too big for you to send to someone else because it's too big a file. There's too much data in it. Could I have it shrink it into a lower resolution file so it doesn't have as much data in it, but it makes it easier to send? That's the same type of thing with us when we're analyzing data. So in our applications, we tend to group them into two categories, ones that are descriptive, just describing, like I've done some, and others where we're trying to make predictions. Descriptive ones is just summarizing. We have no agenda. We don't have a specific objective. Just tell me what the profile is of this customer. That's just descriptive. Because we're not trying to give it any direction and force the description in some fashion, we say it's unsupervised, it's undirected. Um, that and it's referred to as undirected, unsupervised learning. Get to that learning bit in a minute. That predictive applications are ones where I'm trying to predict, is this transaction valid or is it fraudulent? Is this customer going to switch plans or is going to stay with things? Are you going to pass this course or you're not going to pass this course? Is this customer pregnant or not pregnant? I do it by looking at historical data that has the outcomes, pregnant, not pregnant, and what I know about those women. And so using that input data, can I predict that outcome? And I'm looking at a relationship and I'm supervising it because I want the best prediction possible. And because I've got this objective, this measure of good predictions or bad predictions, we view that as being supervised. And we call it learning, again, because I'm trying to teach the formula to work well. In your, if you did quant one, your formulas were formulas. They were all straightforward. If you make this number of units, this is the total cost or this is the total profit. It's a simple formula. But where did the numbers come from? Where did the formula come from? That you need to develop that. And that is a learning process. So we call this learning, and it's being learned by a computer or by a machine, by a robot. And a lot of this came out of computing science. And they talk of machine learning. I'm teaching a machine to learn, and either I'm supervising it, like a teacher directing their learning, or I'm letting them learn it on their own. It's undirected and unsupervised without some specific objective. Just read this book. And if they do learn, they're going to be smarter. They're going to be more intelligent. But it's not a person, it's a machine. So that's artificial intelligence. This language is, I find, very frustrating. It took me a long time to get used to the term machine learning. It um, How do I teach my snowblower to be smart? My snowblower is not going to be smart. Well, maybe in the future, but it um, I the words bring up images that create conflicts in my head. Uh, I get frustrated, but this is the language of computing science. It's the language of data mining. So this is important that you get familiar with some of this language. So the descriptive ones, common applications are clustering, getting groups. People within the group are very similar to each other, but the different groups are different from each other. You don't pick the groups. I don't. When I was doing recruitment, I had clusters for marketing. I'd have Halifax students or a cluster of New Brunswick students, and I'd have messaging for students living at home in Halifax or those that I'm trying to bring from New Brunswick. Uh, but those clusters, I was defining the cluster at the outset. I didn't let the data define it. If I studied the data, maybe I form my clusters based upon what students are interested in, what they like to do. So they could be anywhere. I'm not talking about clusters based upon what they look like or their geography or their program, but something that I've seen in terms of similarities in the data. So with customer data, it may be about their shopping behavior. They tend to shop infrequently, but they make big purchases and they do this, that, and the other thing. So it's characteristics that just came out of the data, not out of my head. Co-occurrence grouping, two things that happen together, or maybe more things, but generally two. So those that bought A often bought B. And that helps us with cross-selling and looking for those patterns. This is not new. That I can remember us using it for layout planning um, years ago, 40 years ago, of activities that took place together. If you did this activity, you would probably follow it with something else, and let's locate those two departments together. Or shopping behavior in a grocery store. If you bought fresh strawberries, you might be interested in making strawberry shortcake, very popular dessert. So let's locate the little cakes that they use for making the strawberry shortcakes, put a display of them nearby, put a display of artificial whipped cream nearby because people will buy them together. And so that was a cross-selling one. The other one that was more devious, and you may be familiar with or not realize, why is the dairy section and the bakery section of the store at opposite ends of the grocery store? And it's because very early on, we found that most people that came to buy bread at the grocery store also wanted to buy milk. And again, maybe you don't buy it as much today, but 40, 50 years ago, that was common. And so because of those co-occurrence grouping, we put them at opposite ends of the store to make you walk through the store past all our displays. And so that when you left the store, instead of just having milk and bread in your cart, you had all these other things that you decided to buy, impulse buying. So this has been around, but this is still, we're using a lot more of it now with data mining. Similarity matchings, trying to find people that look like you, act like you, so that we can then look at the other people and see what did they do in this situation. Maybe that's what you're going to do in this situation. Um, Profiling, it's in contrast to clustering where data created a group that was similar. Here, profiling, I'm defining a group and now trying to describe the group. What's the profile of the group? Serial killers or what have you. Data reduction is trying to compress our data that generally by using less of the data. Feature selection is fewer of the variables. What are the most important variables in clustering? And causal analysis is if we find a pattern, can we use that to explain things? Can that explain why A affects B by looking at the relationship we've seen in the data? And if we understand that, can we exploit that new information? So the cause and effect is very important to us. In predictive ones, there are two big ones, value estimation and classification. Link prediction is second, way down the list. These are the two big ones, and the two we're going to focus on in this course. Value estimation is predicting a number that, so it's like, these are both prediction cases, but with value estimation, I'm going to predict a number, get a number that's my output based upon some input. Classification is a category. Is this fraudulent or not fraudulent? Is this customer pregnant or not pregnant? Link prediction is what LinkedIn does to you of trying to predict people that you may want to add to your network. That do you know so and so? That And so in the Target case, the marketing people got so far as to define, can you tell us which of our customers are pregnant? Um, and so they pose that question, and that's a classification problem. So the data mining people would know, okay, how do we deal with a classification problem like this? The marketing people, because they knew classification was the type of question that data analysts can deal with, it encouraged them to think about what types of classification problems should they are good ones would help them do their job better. So I'm going to skip this because I'm talking too long, but I want you to think about. It described a lot of situations in the discussion. Or if you didn't do it, look at all the ones everybody else posed. They were a lot of them similar about how firms used data to place ads, promotions, to try to change your behavior. Um, think then back, what were they trying to do? What was the data mining application? You're seeing the outcome of it, the way they're using that. But what was the question that they were trying to answer? So they mined a bunch of data about you to do what? Was it a classification thing? Was it a prediction thing? Or were they just profiling you? Think about it, because they're all around us. But this is one where we're seeing the outcome. And I'm asking you to think, where did they start in terms of thinking about question? Um, that maybe I'll have better thoughts about that after I go through what's the process then. So um, I hate the term problem solving. Well, I like it, but I don't like how it's used. So many professors, particularly math professors, say that they teach problem solving. No, they don't. You didn't learn a lot of problem solving in Quant 1. You learned how to solve specific problems. Um, that's like if I taught you how to use carpentry tools, how to use a power drill, how to use a circular saw, how to use a hammer. You learned how to use a bunch of different tools. You learned how to use linear programming, as an example. That, but what was the problem? Even with linear programming, you may have felt, oh, but I had to formulate things. But you were given really structured problems. That how many units should they make of A and B to maximize profits subject to constraints on machine time and resource supply, that type of. They were very highly structured problems, and most of the problems you're posed in your courses are highly structured problems, or at least semi-structured. There's a lot of structure there. What I see in practice are unstructured problems. Um, I'm not even sure what the problem is. I have difficulty formulating the question. I may have a feeling there is a problem, but I don't know what the problem is. It's like when I go to my doctor and I say, I got a pain in my lower back. Right now, I do have a pain in my lower back. I know a symptom, but I don't know what the problem is. Um, that the If it's really structured, it's really easy to find the solution. A machine can do that. That real problem solving is a lot of work. It's more than what a computer can do. And in many instances, I have to do problem finding. My problem is I would like to improve sales, but I need to make that more specific. Can I drill into my data to find out why aren't you selling as many as you should be? I'm going to be searching for a problem that when I solve it will give me better sales. So I'm looking for opportunities. So this search process is going to be called problem finding, but we rarely, uh, I haven't seen any courses in problem finding, but this is an important skill you need to think about that and precisely defining it. So this is a framework for helping you go from the very beginning, that starting point, which is the hardest portion for many, to getting a solution out at the other end. And we're going to use one framework that is called CRISP, CRISP. It's one of the most commonly used ones. It's nothing revolutionary, no super intelligence behind it. It reflects very common problem solving strategies of starting and ending, of defining a question, um, collecting information, doing some analysis, evaluating your results, implementing your solution, and then going back and doing it again. But it uses specific language, and it's, again, useful to know the language. So in CRISP, it starts with what we call business understanding. It's talking to the business people, the ones that have the problem or the issue. And it's working with them, understanding their context, what motivates them, that type of thing, and trying to take that business situation into a data problem. And then thinking of that data problem, that if we can analyze it, we'll give an answer back to the manager that posed the question. And I keep saying business, but this can be in any type of organization. Um, and this is a process that's used right now. It's heavily used in healthcare, in diagnostics, in trying to come up with strategies and that type of thing, new methodologies and the like. But in practically every field, this is coming up as their process. So I'll use business as, what do you do? And a doctor, in a sense, is a business, or a healthcare institution is a business in that regard. Moves through to data understanding, data preparation, modeling, evaluation, deployment. And I'll talk about each of those ones now, what those are. But notice with the picture, it's circular. It goes round and round. And even the last bit, there's a gap between deployment and business understanding. There shouldn't be. We should reconnect those. Look at the outer circle. It says we always keep spinning. The important part of this, and makes this one different from a lot of problem solving charts I've seen that look like this type of wheel, is that the back arrows. Because what is common in data mining, and it's actually common in every problem solving situation, is that we backtrack. As we move through the problem solving process, we learn more, we discover more, and we redefine our problem because we know more now. And instead of, if we realize, oh, we're on the wrong path, instead of blindly keep going, we go back, change, recalibrate, reset our direction, and go through again. So it's very circular. And the back arrows, I think, are the most important part, the most valuable portion. If you're going backwards, it meant you learned something. Going forward, it may be you're blindly going forward. You may have been doing that without thinking. Going backward generally requires deeper thinking. And so I view, like making mistakes, I view as a positive thing, because it means you're going to learn from them if you reflect upon it. That, but they're all interconnected with each other. You can't look at them separately. They feed into each other. The players may be different in different stages, but you should have some continuity in moving from one to the other. Don't do a simple handoff. You'll probably drop it. The next stage doesn't understand you properly. Communication is critical. And many people join stages together. I have difficulty doing the data understanding without actually getting in and messing with my data, which involves what we call data preparation. And some of my messing actually involves modeling. So I tend to do several of these stages concurrently. Um, as time goes on, I'm moving more from data understanding towards modeling. But as I'm moving through, I've got so much back and forth, it's hard to tell that I'm in one stage or another. But what are those things? What do they mean? Each of them Understand them by what questions you ask at them. Business understanding, it's what's your goal? What are you trying to achieve here? Um, if if we were finished, what would the outcome look like? What would success look like? Could we measure if we were success? Think about the outcomes. Don't think about where you are right now or any of that. Just think about, dream about the outcomes of the future. Too often with a meeting, you go in there and people argue and debate and it goes on and on and on. It's like, oh, that this meeting ends at 11. What time's our class end at? 11:15. At 11:15, where are we supposed to be? What are we supposed to have at 11:15? And can we say whether or not we've been successful in achieving that? What's the outcome of the meeting supposed to look like? And if you go around the table, more often than not, you find everybody has a different opinion. If they can't agree on the outcome, you're never going to solve the problem because you've got the solution for one person around the table, but not for the rest of them because they all came in thinking that the objective was different. You've got to bring them together in terms of that. What is the outcome on it? You've got to focus on outcomes. And you got to think about the players, that who's going to make the final decision. You're tasked to go and do something, but in the end, someone else is going to implement it. I can remember being on one task group developing a set of recommendations on a particular issue, um, a very, very important one, but it was driven by someone leading the committee that had his own agenda and thoughts and didn't think, he was so focused on the outcomes he wanted. He didn't focus on the decision maker, which was going to be the president of the university, not the current one, it was a previous president. And didn't think about that individual, how that person functions, uh, how much, how hard or easy it would be to implement the decisions. Ended up writing a report with recommendations that were impossible to implement. Politically, they were just be disastrous. But if they'd been tailored differently to fit the actor, the final decision maker, could have achieved the goals we wanted really well with a lot of support by phrasing it, by implementing it differently, by um, anyway, it you have to understand those. And it is not unusual to have models where we end up with the outcomes at the end that the users will not accept, or those that are supposed to carry them out will fight it all the way through. You've got to think about them and how do you get the buy-in? And your strategy for solving it is going to be dependent upon that. So at the very beginning, we're going to be thinking about these issues, about shared values, objectives, conflict, the level of understanding of the users. Is this too complicated for them? Is it too simple for them? And generally, we're trying to take that broad question and rephrasing it as a data problem. If I know this, then I can do that. So can you tell me, can the data tell me how to do that? That we need to phrase specific questions. So we start with this general objective. The next stage may be a set of 5, maybe even 10 well-defined questions that if we can answer all of them, then we have our answer. We know what to do. That is hard to do. It's a lot of work, takes time. Don't rush it. Um, so with Target, if I knew which customers were pregnant when the baby was due, I know I can do my marketing job better. That's my business problem. So my question is, can you tell me which customers are pregnant? Can you tell me when their baby is due? Actually, later they're going to have, can you tell me the best marketing strategy for the ways to influence this pregnant customer? So those are further ones on the implementation. So how am I going to use that information? That's further data mining questions. I'm going to be using the US presidential election this morning because it is a data analytics problem. Um, as to what sort it is. Give it some thought. I'm going to rush you through, but I want you to think about it. But if you've got thoughts, please throw them in as we go and think about these steps um, with the U.S. election, because it's been in the news so much of late. The business problem could be seen various sorts of ways. One is choosing the leader of the United States, and what does that mean? As what's a leader and so on. Some may view it as a simple classification problem. We have two candidates, Biden and Trump. We'd like to classify one as being the president and the other one as not being the future president. It's a classification problem, and it's one where only one can be president. That, um, but the business problem is actually very, very complicated, because then we're starting to think about what do we mean by what is the president, and when you're thinking about what's success in that selection process. This has been a very difficult selection process and a very hurtful one. Um, and so if I was looking at this as my problem, I should also be looking at the process. And is it been a destructive process in making the decision? Because this is one where the process has been getting all the attention, as well as the outcome, the prediction or the decision at the end. It's even unclear who makes the decision. Is it the voters? No, it's a thing called the Electoral College. And how does that work? That do the users have shared values and objectives? Obviously not, or we wouldn't have demonstrations and so much controversy about this. There's a huge amount of diversity, and maybe part of the process should have been on, is it to select the president, or having a process and selection that the vast majority of Americans will buy into and support and help move forward? Because this isn't just a choice, it is actually a statement about what the US looks like over the next 4 years. It's more complicated than just Biden, Trump sort of thing. And a big problem is that generally Americans and Canadians and most of the world have no understanding of the process. It's a very complex selection process in the US. And because they don't understand it, they don't trust it, and they argue about it. Um, so moving there, it's a data thing. So it's a data-based problem because it uses votes to make that. And we have a process of votes or data that, um, what data do you have? You don't, before November, in the election, they didn't have the votes. But so they were going to need that. But then it was trying to think about how do they get it? How do they obtain the votes? And who should be allowed to vote? Which votes? Um, what does that data look like? And what do those votes look like? A few elections back, um, the data looked like punch cards. They were chads. They had voting machines, and I think the controversy was in Florida, where the voting machines ended up producing defective votes. Made it hard to figure out who did this person vote for. Um, and we have to ask about the quality, and we'll talk about that later. Um, there's debate about it. With Target, they had a lot of data. If you read the original article in New York Times Magazine, that they talked about just how much data they collect on their customers, and in addition, they can buy more data. Certain things you can buy data, less in Canada. I think we have greater privacy restrictions here than in the US. But in the US, they can buy a lot of data. Sorry, Dora had to leave. um, in Target's case, they had a baby registry. And so that was where they were going to draw their data from. And they know a lot of purchase behavior at Target, not at other stores. Okay? Um, but they know a lot about the shopping behavior at Target of those customers that were in the baby registry. There's a lot of data they didn't have because those customers may have shopped elsewhere for a lot of their other types of items. And so building this profile, the only purchasing profile they could build was around Target shopping. But they can then work at that as their data source. With the election, that there's two types of data we've got there. One is the actual votes, and then is how that's converted into electoral college votes. Um, every state is different in their procedures for collecting that data. It's a very decentralized system. It's not like in Canada or many countries where the voting system is done on a national basis. In the US, voting is done on a state basis. And then that creates the electoral college that then is dealt with. So they have data and then data that's been transformed, the electoral college votes. That with most data sets, we have missing observations. With the survey that I'm having you do, because I'm trying to build a profile of students this winter to compare to students from last winter, those that don't answer the survey are viewed as being missing observations. If you started the survey but didn't finish it, then I've got some data on you, but I'm missing other data about you. And I don't know what the other data is because I don't know what the other data is. um, those that did not answer the survey, I don't know much about because they didn't answer the survey. Um, it being totally anonymous, I don't even know who it is. I know with the software I'm using, it goes and pulls from that list, but it doesn't tell me. It just tells me how many have answered and how many haven't. But I've set it up such that after I started it, I knew the original list of people invited to participate. But after that, I don't know who is and who isn't participating. So I don't know anything about the missing students. And maybe they're different. Maybe the ones that answered right away are the keeners that always do what they're told to do and that type of thing. And the ones that haven't are maybe the students that are most likely to have problems in the course because they're not as engaged. But I don't know because they didn't answer. I'll get some errors that happen in terms of data entry and that type of thing. We get that. And some of the data that we get just isn't valid. Doesn't make sense. That and we will talk about that as we get into the data understanding. That'll start fairly soon. That's our next class, start data understanding. That, but the with that one, um, the election data that we've got for the U.S. Um, there's been a lot of debate about people that weren't allowed to vote or whose votes weren't counted. That is that fair? Is that honest, ethical, whatever? Um, there's questions about whether or not votes were changed. They're saying that the voting machines were set up to change votes from Trump to Biden. Um, that's not data entry. That's errors. That's fraudulent activities that are going on. But that happens in that. Try to understand the process. And should you believe the results? So when the data actually arrives, we do some cleaning. We try to look for outliers, strange values that don't belong, and maybe throw them out or investigate them. We may recode our data or transform it, filter it in some fashion, generally in a positive sense to ensure that we're not being distracted by garbage, trying to sort the garbage out. With Target, to make it in a usable form, they had so much transaction data that they compressed it. So um, with body lotions, they probably didn't care about what brand, what size bottle it was, when it was bought, maybe, and just said, what's the total amount of body lotion you bought per week, or vitamins, or those different things. So they aggregated things. That's part of the data preparation cleaning process. So they're summarizing the transactions, condensing it. With the election, there's debate about cleaning, and that's some of the cases that have happened. The Electoral College is a case of how they're transforming those votes into Electoral College votes. But there's been a lot of debate about who was allowed or not allowed to vote. Should they have been allowed to? Should they treat mail-in ballots the same as in-person ballots? Are those valid ballots? So those data quality issues and um, court cases, to some extent, are about that cleaning. That some groups want some stuff cleaned out, and others keep it left in. So we try to build a model, and that's often in terms of formulas. Sometimes we use more than one application on the same data set. It isn't just one method. We may use multiple ones. That and the output of doing this may not be a formula. It may be pictures. It may be some rules to follow. Um, some other sort of thing. Sometimes it can be very creative. That uh, and there isn't necessarily a best method. We'll talk about that issue. Um, that there are generally lots of methods to choose from. So Target, um, they built a model to come up with a pregnancy prediction score. So they came up with a number for a woman that said, I think there's an 87% chance that woman is pregnant. And so they assigned a number. And then based upon that probability, they would classify her as being pregnant or not pregnant. So based upon a scoring system. That's a common strategy in classification. Um, that so that they may have used multiple. They had different models for different questions they posed, and but would come out with some type of output. The election in the U.S. Uh, they've got a complicated process that goes all the way from the way the primaries are set up and candidates are considered, and who's the Republican candidate and the Democratic candidate. They have that electoral college system. There is a modeling process, in a sense, that they've gone through with different models being used by different states to pick their electoral college votes. And each of those are ones that are supposed to be creating transform data that reflects what this state feels about who should be president. And each state approaches it in their own unique fashion of how they take votes and translate that different. Um, and then so that is a model. That's a process. So a process is a model. They're both the same. We should think about evaluating this before we go and try to implement it. Every model we use makes mistakes. We make classification errors, predictions that aren't perfect. Um, what are the consequences of these? What's the difference between predicting someone is pregnant when they're not, or predicting someone is not pregnant when they are? Are those errors the same? Consequences the same? That um, often they're different, and we need to take that into account. With Target, they were able to evaluate how accurate their models were, and again, these are quotes are being taken from the original article, but uh, uh, they haven't spoken necessarily about the errors in their prediction. Generally, in evaluation, we're going to have to evaluate errors and the consequence of errors and of getting things right and the consequence of getting things right. And what's the balance between those? With the election, how would you evaluate this model's performance? It's not over yet. Decision final inauguration is in another 9 days. What's going to happen then? And the consequences of that decision are going to be felt for the years after that. That how would you evaluate this model, this process that they've gone through? It's been a very, very destructive process that they've followed, unfortunately. And it's not just local in terms of within the US, the rest of the world. How do they feel about this process and the outcomes and how that affects relationships of the US and the rest of the world? Um, that we view as part of our evaluation process. And then we try to implement it. That have we actually answered the question that was posed? Do we think the users understand our recommendation and why we've made it? Are they going to accept the decision? Um, it's probably something we're going to have to repeat over and over again. How are we going to maintain that? Are there any ethical issues in implementation? Like, are we scaring our customers because we know so much about them? Unintended consequences? I don't know if the violence and the like, for some, you have to wonder, was that an intended consequence? It's just, it was so preventable, the storming of the Capitol and what happened there should have been prevented. So that seems like an intended consequence, at least for some players in this process. Um, but there are others that are unintended. And what's happening here? Um, so there's a lot to think about in that one. This one, it's been a very awful process. So with Target, once they were able to um, identify customers and the timing, they had their deployment involved other data mining applications that involved how to then influence Jenny's behavior and make her shop the way you wanted her to shop. So there were, what happens now that we've found who's pregnant? What are you going to use that? How are you going to use it? And it's important to know what those sorts of things are. And some of them may be inappropriate. So they used additional models to do that. But one of the maybe unintended consequences of this process was because they were so successful, the profile of the data analysis group improved dramatically, and it allowed them then to do other projects. It got them stronger support for future projects that they did. It gave them credibility, and uh, that so they're one of the actors in the process. It isn't just the marketing people. There are other players, and the way you unfold this and the way you implement it and deploy has ramifications not just for the final decision maker, but others that are in there. And you should think about that. I've described these steps, for data mining, but it applies to any type of decision-making process. Um, with the U.S. election, I don't know. There's just so many things you could say about it. But this has been a decision-making process, a data analytics-based decision process that has been fraught with controversy, and it's been horrible. That they could probably make it better by redefining how they select their president. For example, um, just pick the president that gets the most votes. There are certain communities would be dead set against that because Hillary Clinton would have been the previous president because she got more votes than Donald Trump. Um, and many would argue that popular vote's not the best way to make decisions. It's simpler. It may have resolved some issues, but maybe not others. But at the end, when we're deploying, we're often looking back at lessons learned. And if we were to do this again, how would we do it differently? So it is a process. It's not a formula. You do need to think about all these phases. And we don't emphasize enough in our courses all of these steps. And so we see, and I've seen in my experience, so many bad decisions or good decisions that came via a very bad problem process. And so the outcome was not uh, as successful as it should have been because the process wasn't managed as well as it should have been. Uh, I've got, think of ones where, yeah, the initial outcome may have been fine, but it was a repeatable thing and they didn't look at maintenance. And so, yeah, you implement it for this year, but what are you going to do next year? And it didn't get carried forward. It died. A lot of work went into something that should have been a continuing thing. But there's a lot of things. These processes and the data are both very messy. That it's helpful being able to have pictures, mental pictures of of similar types of problems. They give you good ideas of how to attack a specific new problem. And you're not finished until that outcome is implemented in the way it's supposed to be, and we can measure success at that end. It's not when you make your recommendation or your decision. The decision has to be implemented. And so even after January 20th, we won't know. Uh, we shouldn't evaluate the outcome of this process because there's going to be controversy going on for many months, possibly years, probably years to come on this one. Um, so what's next? We're going to look at that data understanding, and that we're going to try to discuss what does data actually look like? What problems should we be aware of? So this is chapter 2 that we're starting in on. And on Wednesday, I'm going to be talking about all the different types of issues. And next Monday, we're going to be using Excel to look at a specific data set, a survey from 10 years ago that has got a variety of problems associated with it, as most surveys do. This one probably no more than a lot of other surveys do. But it'll give you insight as to how, when I say data is messy, what do I mean by that? And how can we clean it up and make it easier to work with? Um, I am not going to get into Hillary thing now. The other class, one of the fellows asked that we talk about this one. It's a blog written by a woman. Her name is Hillary. Her first name is that. She is a data scientist, and she writes a blog about issues in that regard. But back in 2013, she wrote on one of her blog posts, so this is quite a long time ago, was her frustration with her name. And that is interesting, the timing of it. Um, Her first name is Hillary, and quite a number of years ago, Hillary became a very popular name because of Hillary Clinton. Not so much because of Hillary Clinton, but because of her husband, Bill Clinton. Bill Clinton, hmm, um, uh, there was certain controversies about him as the U.S. president, but he was a very charming, affable fellow. Everybody liked him. He knew how to work a crowd beautifully. He engaged people. They warmed to him, and so on. Uh, and Generally, Americans loved Bill Clinton. They, as a person, they liked him. And Hillary was his wife. And in the previous spouses of presidents, stayed in the background. You know, they baked pies and cakes and did housey things. You know, a very 1950s vision of what a woman should be like or a wife should be. But they liked that. And Hillary Clinton wasn't that sort of person. She was very outspoken, very intelligent woman. She still is a very intelligent woman. Um, and she was very active in politics. She was a senator. And So she was active in politics. And she is not a warm and fuzzy person. She doesn't have the warmth of her husband. And so initially, people didn't know that. She wasn't well known to Americans before Bill Clinton became president. And so when first he came in as president, Hillary's name got used for a lot of babies that were born. But then as people learned who Hillary was, uh, they decided no, they didn't want to name their child after Hillary Clinton. And it became an unpopular baby name. And Hillary, that wrote this blog, um, she hated the fact that her name was Hillary because people connected her with Hillary Clinton. And so she wrote about this sort of thing. But she made a statement that it was the most poisoned name in U.S. history. What does that mean? And how does she prove that it was the most poisoned name? And so the blog talks about that. It's a data analysis problem. And it's a story. It doesn't have any fancy math in it of her journey of trying to convince people or convince herself that it was the most poisoned name using a lot of it very simple techniques. And it's a very, I enjoyed it as a story to read, but it's a story and a lot of data analysis. Good data analysis should be good storytelling. Um, if I had some students from Ontario, at 8:30, Ontario should be releasing its COVID predictions. And I made mention, well, you should look at, let me just end this if you don't mind, the presentation. Come on, get out of here. So get rid of my slides. This is a website I like going to called 538. It's an American one. The fellow likes studying data about politics and sports. And that 538 is the number of electoral college votes that exist. And one of the things he tracks and has been tracking is stuff about COVID and forecasts. And this was a big deal back in the spring. How many people are going to die from COVID in the US and by certain dates? And there was a lot of debate in the spring about the different models that were out there. And so when I'm saying there are different models and which one's better than which, uh, on their site, 538. Also, if you're really into sports and US sports, NCAA sports or NFL or any of those sorts of things, there's a lot of interesting research on who's going to win. If you're into a betting pool, here might be a good spot to get some good data for you. That, but with the projections, here's an example of the number of deaths in the U.S. back from the beginning of April up to the most recent this weekend, and then the projections. What's going to happen by the end of January, January 30th? So here, Columbia University says it's going to be 398 deaths by the end of the month, maybe as many as 424. UCLA, oh, that thinks it's going to be higher, 402, but it doesn't think there's as much variation. It thinks it's only going to be plus or minus maybe 2,000. I think they're crazy to be so accurate. But it talks about how they built them, that they have different assumptions about increases in infection rates and what states are going to do and how they're going to deal with things. And you can go through all of these different ones. Here's uh, the most pessimistic of the models. Uses mobile phone data about the way people are moving around and tracking that information and seeing, um, is your bubble big or small? They're predicting by January 30th, 453,000 deaths, so 50,000 more, and maybe as many as 469. So we get different, whose model is better? Their short-term accuracy has been generally similar across them, but they all use different assumptions and different models. They're using different data to answer the same question. Um, so as of January 10th, Johns Hopkins says we've got 374,000 deaths. And you can look at these ones. It's an interesting, you can go back in time and see what forecasts were being made at the beginning of December for these different things and what actually happened as to where their forecast was and what the actual was. So we can do, these are examples of way you could visually see evaluation. So there's a lot of stuff that can be done, like in the blog about Hillary, that we can do with simple graphs. And those become our models to communicate and explain what we've done. The models behind the scenes in this one are very complicated, but they have different assumptions, so they're different answers to a similar question. Back to our class. If you're still there, I've run out of time, so I really should end the class. Um, oh, Nathaniel has given the website for it, 538. Thank you. I'm not sure what else was in chat at that point, but oops. Oh, thanks for scrolling back for me. I wasn't able to scroll. But anyway, I'm going to end it for now. That please participate in our survey, get us some more data. You can see me on Wednesday. Remind you again, you don't have to attend classes. This one, hopefully, The video has been done properly, and I will be uploading it within an hour or whatever, and I'll try to do that with every one of the classes. I like it if you're here, but you don't have to be. It can work with whatever your schedule is. And so you take care, and we'll see you on Wednesday. Oh, um, send me pictures, please. Yes, yes. Give me some more pictures. I'd like that. Not just of outdoors. Maybe it's just of you and your friends. Um, Send me pictures of things that make you happy. Um, don't send me sad things if you can, but things that make you happy. I've got a picture I will be using in the future. Some may think is sad. It's it's part of a story of, I think, of happiness, um, but it's a very different one, and I'll try to be using it probably next week. I'm going to use it. So you take care, and I'll be back on Wednesday. Bye. Yes, I want to end the class.